Let's have a look into the first component of the steam system, which is the boiler feedwater treatment. Um, Principal problems with raw water, either you take it from the reservoir, river, lake, borehole, or seawater desalination plants, is that it is not pure water. So from those raw water, there are contaminants. Some of the contaminants include the suspended solid. We can have a dissolved solid, dissolved salt, and also dissolved gases. All of these contaminants we don't want in our feed water, boiler feed water. Therefore, okay, we require the treatment of this raw water. So what is the typical treatment units for boiler water? So first of all, we do a filter to remove the suspended solid. This filter can also be used to remove the hardness by using zeolite. Let me add here. So this filter is basically remove hardness. Which is coming from calcium ions and magnesium ions. So it can be used. It can be done by using a zeolite. And of course, if you use a zeolite, you will. So the adsorption capacity is limited. There will be a cycle of. There will be a cycle of processes. Yeah, the cycle of processes to activate back the saturated zeolite. So next step is ion exchanger. This unit is basically to remove any dissolved solid and also dissolved salt. Okay, this unit is to remove okay. You can have one we can have few options. We can use ion exchanger as shown here. Basically uh, it, it, it consists of the anion exchanger and cation exchanger. Anion exchanger is used to capture any cations in the feed, and you also have anion exchanger to capture any uh, anion in the feed. The same as in the zeolite, you have some limit in the exchanger, so there will be a regeneration process required in this. Okay. So the next, so this basically to remove dissolved solid, also to remove dissolved salt. So the next process is we also want to remove dissolved gases. This is to remove mainly oxygen and CO2. Why? Because these gases are corrosive, and normally it is done by using steam. So this is one of the user of the steam. So we use a steam to heat the feed here. When you heat the feed, we then the solubility of gases normally lower at high temperature. So by increasing the temperature of the water here, we can remove both oxygen and CO2. Okay, the next step is actually this is one step. This is basically a chemical dosing. Yeah, the chemical dosing is used to further refine the water. Okay, to further refine the water. Um, Here, basically, some of the chemicals that's used can use the oxygen scavenger. Can also be phosphate. phosphate is added to react with some of the residual calcium and magnesium, uh, the chemical can also be a chelating agent, chelant. The function of the chelant is basically it's basically a weak organic acid that has an ability to complex with many cations, for example, calcium, magnesium, heavy metals, and so on. And sometimes polymer dispersion also add here. So why? It is to disperse some of the residual solid that cannot be removed through all of the treatment before, so that it is keep in suspension, not to precipitate in the boiler. So after undergoes a lot of a few steps of the refining process, then the water enter the boiler. So in the boiler, you see here you have two streams, yeah, for the water. So the first stream is the steam itself. So this is basically the steam. Okay, the other one is the boiler blowdown. So the blowdown here is basically to the objective of the blowdown is because of after processing with a lot of pre-treatment, you will still eventually have some of the solid in this stream. So to be and then since the steam here is the free from solid, basically then you will have a solid accumulating inside the boiler, and then to prevent for the accumulation, then there is a blowdown boiler blowdown system. Okay, so the system then goes to the steam system, like what we discussed in the previous video. So from the steam system, we have two streams. Okay, first of all, some of the condensate is lost, and then some of the condensate can be recovered and then pipe it back to the aerator. Okay, recycling steam here can go to anyway depending on the quality of the condensate. So in this example, it goes to the aerator unit. But if, for example, somehow or another the condensate contains a lot of dissolved solid, then most likely it will be sent to this unit. Next question is how much we can return. Typically, it's less than 90%. Okay, why? Of course, we can return the condensate as high as possible, but the problem is that investment cost. So maybe in one condensate stream, the flow rate is too small, and then it is not attractive economically to just to pipe back the condensate to the return condensate stream.